Section 6.2 is differential equations, growth and decay. The first part, questions 1 and 2, feel very much like what we just did in section 6.1. It says solving differential equations. We're just going to solve what we're given. So what did we do in the last section on this particular type of problem? What's the last thing we just did? Right, the antiderivative, yeah. So the first thing we're going to do is we're going to move the dx over. And the second thing we're going to do is we're going to integrate both sides. So what's the antiderivative of dy? Y. What's the antiderivative of 6 minus x? I'm missing something. Plus c. Yeah, and we're done, right? That's just like the last section, no differences. This one's a little bit different. Oh, I'm sorry. You got it? Okay. The next one changes things just a little bit. You'll notice to begin with, it's not written as dy dx, right? It says y prime. Well, it's the same thing, but we do want it to be written as dy dx so we can move the dx. So the first thing is to actually recognize that this is dy on the right, or on the left, excuse me, and I am going to put a dx on the right. Now, there's something else that's a little bit different about this one, though. There is a y on the right-hand side, isn't there? Yeah, we don't want that. We need to separate because our antiderivatives that we know how to do involve only one variable, correct? So we need to move the part that has y on it onto the left-hand side and leave the part that has x in it on the right-hand side. How are we going to do that? We're going to divide. Okay, so let me actually show you if you were to distribute the problem that you'd run into so that you can see why it won't work. What's that? Yeah, one of the problems is that you'd have an xy and a y over here, and you'd have both of them. The bigger problem is that they're actually both multiplied still by dx. Right? Yeah, we don't want any of that. None of that's good. But if we divide by the 1 plus y, we completely remove it altogether. So I'm going to have a 1 over. What was that, Nate?
Yeah, but it's still the same problem.
Yes. You're correct. Like this. Does that make you feel better? Yeah. Here's the problem is that you still end up with two pieces. Well, in fact, it's even worse than what I was explaining. How's that? You've got an x dx plus you'd have an xy dy, or xy dx. So to move it, you'd have to move all of this, and it has x's and dx's in it, and that's awful. Yeah, so this is absolutely no good. We don't want any of that going on. But the division actually works really nicely. So it looks like this. So do we have all the y's on the left and all of the x's on the right? We do. And once we're at that point, we're able to take the integral of both sides. Now, this is different because before, the only thing we had on the left was dy, and now we've got other stuff with the dy. Let's do the right-hand side first. It's easier. What's the antiderivative of x? X squared over 2. And we're going to have a plus c somewhere. We'll put it here just for fun so that we can do it for now. You tell me what we're going to have, Caleb. What do you have on the left? You have a natural log, and Kate, this is where, or Kate, this is where you're going to have the 1 plus y with the absolute values in that you were asking about on the last questions, right? You do have absolute values here now. Now, we could put a plus c on this side, but really, I don't care where I put the plus c. I need it one place or the other, but I don't really need it both, because I could consolidate two c's into something else anyway later. So I'm just going to put it on the right. Okay, is everybody good with the natural log of the absolute value of 1 plus y equals all this stuff on the right-hand side? Now, we're not really done on this, though. Any idea why? Yeah, it doesn't just say y equals, right? And if you're finding a solution should say what in the world your equation is equal to. And right now, we've got sort of this mixed version of what it would be. It's all mixed up. I need to solve for y. How do we solve for y when there's natural logs involved? Yeah, ease, good. Okay, so this is going back into chapter 5. See, this is why I love chapter 6 so much, is because it really takes all these pieces of things we've been doing all semester and helps you to remember all pieces of it. This is an exponential problem now, right? So instead of it saying natural log, I can put, and I'll actually write it in on this one, e as a base on both sides, yes? And the e and the natural log, in essence, cancel one another out, so I get 1 plus y on the left. On the right, I get e to the x squared over 2. And technically, well, I'll write it out just so you can see it. E to the x squared over 2 plus c. The c is actually the way it's written right now in the exponent. I'll show you how we can fix that later, okay? But I need to solve for y, so what else do I still need to do? Move the 1 to the other side. So in some versions, you could actually have this written e to the x squared over 2 plus c minus 1. But man, that's ugly because the constant is up in the exponent, correct? And that's probably not how you're going to see the general form of the differential equations solution written. What are you going to see? Well, here, let me show you. This is the same as e to the x squared over 2 and e to the c. Properties of exponents say if we have addition in the exponent, it's the same as having the base to that exponent, and the exponents or the bases are multiplied. But what is e to the c? Some number, right? Now it's not the same number, agreed? But it's some other number. So we're going to change something real quick to make it nicer. This is like having a c1, and then e to the c1 is some other c. You have to be careful. It's not plus c, right? This e to the c1 right here, it's multiplied by e. So it's a constant multiplier for what we had before. So it is c times this constant, or this function we had before.
Simply wait to add plus c.
Couldn't you put the
You
c
can't.
on the other side initially in order to make this problem?
You're going to see the c multiplied in here with what we're doing later. So that's why we're going to put it in here for like this right now. Yeah, you're going to see this as a c multiplied.
You could just put it within that control log. 1 plus y plus c, 7 minus c.
Theoretically, yes. But we're working with growth and decay in this section, so you're going to see the c multiplied on the right every single time. Yeah, that's how they're going to show it every single time. All right. So, and I know this looks kind of funky because my x squared over 2 looks funny, but it is x squared over 2. So our general solution for this differential equation is y equals c times e to the x squared over 2 minus 1. All right? And we'll stop there.